Who am I? Not a game developer, but this talk is based on a lot of research and talking with individuals who are actual real game developers, people that have worked on various layers of the stack. What I do actually do is I contribute to upstream projects like Istio, like Kubernetes, most recently, a bit of Envoy. My contact information will be available at the end. I have a few business cards if you really want one, but not very many. So catch my email at the end of the presentation if you want to talk more. On the flip side, I'm a tank bone chewer on the bone chewer realm. I play AD carry, and Here's the Storms in League of Legends. Protoss for life. Agenda-wise, so I've swapped out a lot of slides. I've put in more slides, taken out again, talked to a few people, ripped out a lot of slides, put more in. If you download the slides before this, I'm sorry because they are not the presentation you're going to see here. But we're going to go through a few of just the basic problems that I've seen a lot after discussions and after some research. A few basics just for people that aren't very familiar with Envoy. And then a couple of use cases that I think could still be applicable in some scenarios for gaming, even if you're not ready to put a proxy right in front of your game engine. Quick poll, who here works in the gaming industry? Excellent. So anything that's wrong, please immediately correct me. So a few of the goals. We'll start with just a few high-level goals of some of the interesting things within game engine code. And our first kind of goal with a lot of this is scale. And scale means a lot of different things depending on the type of game. We have very smaller kind of things, more of an older networking type of LAN party, similar thing, maybe more familiar to the analog like Dungeons and Dragons sort of scenario. There's one dungeon master, there's multiple players. If the dungeon master dies halfway through the campaign or needs to go home, you need to elect another game master. So a lot of these, a lot of your network problems in this scenario are really based on the game master there. And if that player's connection is particularly bad, everyone else suffers as well. One kind of benefit to this is you do have the ability to migrate hosts, but it's going to be quite obvious for everyone as they go through the game if everything just kind of stops and then you transition to a new host. Then we have the dedicated game server model, and this is what I've noted as one of the more popular ones. Very familiar for people working with maybe like an instance in a larger game, like a dungeon that you're running through, perhaps, or even just a normal first-person shooter type of scenario where you basically have a round, winners declared at the end. So in this game model, you have a process running on one dedicated server, hence the title there, and this will have your game server engine running. And everyone connecting from either their Xbox or their PC is connecting to this one game server engine. Is there a load balancer in between? Normally not. You're going to expose this IP from your general list of all the IPs that your cloud provider is going to give you, or maybe you're hosting this yourself. And they're going to be connecting literally directly to that IP. So there's nothing in between here. Once the round is over, whether there's a winner or your server died, you can either resume with the same process, or you can recycle the whole game engine so you don't get any cruft laying around or any other sort of inconsistencies when you're updating your game. Important note in here, you're not going to get your host migration. So if the one process dies, everyone's affected. The game just kind of ends, no winner, everyone upset. The good news is this generally doesn't happen, but it can. Then you have another scenario where you have like a massive sort of world. This would be more like your large-scale MMOs, different parts of the map maybe being served from a large majority of servers dedicated to that specific purpose, that specific serving scenario. But inside of this world as well, there could be a bunch of people sitting in one general location or spread out. And you need to be able to track everything that's going on within these certain things, from people actually battling each other to random people dancing in front of a bank in a larger city. So performance-wise, this is kind of the thing that comes up always. It's the #1 thing on everyone's mind when they're working with game servers. And it's difficult to prioritize performance, especially in a game scenario when there's so many factors that go into just one message. When you're thinking about kind of the messages and the pieces in the game, you could think of them sort of like a large-scale chess map. And as we know, each piece on the chess map has its own details about it and its own attributes. While running along the board, it's most important where the chess piece ends up rather than maybe all the steps that come along. But there's also rules that go along with each piece. There may be multiple games going on simultaneously. You need to, and other players might not be looking at the other games going on. And we can separate some of these different events down into things like control data, where I'm moving left. State data, player 2's in the chopper, or now the chopper has exploded. An event, I'm firing my weapon, perhaps. So to tenantly scale, a lot of game developers will take a very prescriptive approach and use something like UDP in order to prioritize what's happening as far as what message is most important to be sending at this time, what messages can I dispatch of. Utilizing TCP is similar to joining like a large enterprise meeting. You get halfway through the meeting, find out everybody's muted, find out someone all of a sudden, this time slot doesn't even work for them, so we need to reschedule the meeting and deliver everything back. That sort of pause and ACK and NAC sort of event and sequencing just doesn't reliably work for fast-paced scenarios like a game. As well as to a person playing the game, this might end up being them running across the map, suddenly stopping, and then ending up like 50 feet from where they imagined they were supposed to be in the first place. So UDP is quite simple. You simply take whatever you want, you're throwing it in the packet, and then just tossing it over. And prioritizing what to place in the packet can also be a difficult thing. As I mentioned, positioning-wise, it might be more important for all the steps that you took to be thrown away entirely. Because if I'm a player approaching you with, If I'm approaching you, I want to know if you're right in front of me, not where you were 10 minutes ago. Unless I'm sniping, in which case, you always want to know. Availability is also a very common thing that you'll notice it when deploying your game servers out. And this actually becomes an integral part of planning the actual game in general. You may start out with a few given zones and allow players in the dedicated server model to only connect to those zones. But in some scenarios, they might figure out how to connect to them anyway in a country maybe that you're not in. And then a Twitch streamer picks it up, the game becomes really popular, and now you've got thousands and thousands of players connecting to an area that you did not intentionally think that they were going to play in. Then you end up deploying servers there to actually support them, and then people never want to migrate off those servers because now they've developed a community, and they don't want to switch to one where their friends aren't playing on. So it's a difficult balance. You don't want to break apart these kind of general social instances that pop up in the game, because that could just ruin it for everybody. Security-wise, you'll also face interesting problems. Turns out people can be really terrible. If they die in a game, they might feel it necessary to DDoS your game and ruin it for everybody, because if they died, everyone else should die or not be able to play in general. On the other hand, people take a different approach and decide that they're smart enough to reverse engineer your binaries and figure out how to get all the great weapons, and then they just wreak havoc on everybody in general. Fleet upgrades is another interesting scenario. As we mentioned in the dedicated game server model, it's pretty easy to spin down that instance at the end. But what happens if you're constantly playing with the same sort of maps? How do you relatively deploy new instances of your game, such as maybe something like adding voice features to your game so that you can interact in a scenario that you didn't allow something like multiplayer in before. So in this instance, we have the Star Trek Bridge Company game, if you guys have played that before. In the game, they recently added some, well, not completely recently, but there was support added for playing without connecting with 4 people. So how can we actually deploy this sort of feature out without affecting people that are currently playing and making sure that when people actually do connect, that they can use this sort of voice feature and they're not just left alone trying to figure out what's going on with their game. So we want to maybe selectively route people to more of the quality assurance type of machines to test these features out, or else only silently release this to some specific group of individuals. What are some things that we can do in the game community for that? So this is kind of where we come to like some of the basics of Envoy, which I've targeted at this solution. Now there's going to be different use cases of Envoy, and talking to people, they don't really have the appetite to place Envoy potentially directly in their game server path. If I give you a bowl and a spoon and tell you you can use it to make ice cream and fruit salad, it's not very useful to you if you already have an ice cream maker and you only want to make ice cream. So I don't expect that some of this will be applicable to someone that will want to immediately rebase all of their game engine code on top of Envoy. But at the end, I'll describe a few other scenarios that I think are still going to be applicable. But what Envoy really is it's target, man, this thing. It's an intelligent proxy normally deployed as either a sidecar or perhaps it runs on the host. And what it's going to do is it's going to intercept the traffic coming from service 1 in this instance, running on the node, and tossing it over to the other node by way of talking to the other node's Envoy proxy. So it's sitting directly in the middle here. Listeners are used within Envoy to represent normally what type of method is being exposed. The listener proxies events whenever connections are made, and you can tweak various filters to kind of augment different connection aspects prior to handing it off to its next service. There's different methods or different binding options like free binds, as well as options like the transparent mode where you can kind of represent things that aren't immediately on your server, but you kind of know where they are. It'll toss them over there. Then there's the notion of a cluster. Clusters within Envoy are a collection of normally similar hosts that Envoy can make connections to. For example, each instance of a web server or other type of a game network that's just processing events for a specific event will be represented within one Envoy cluster. And you can dynamically configure clusters of these services through various APIs or statically assigning them through things like files. Another good aspect of clusters is if you've got some preparation before you can actually start adding and removing different instances and putting them back into your load balancer pool, there is some warming in the options that you can have so that you're not going to immediately accept a connection and fail because you haven't properly warmed yourself up and received all the information you need. And then the last small component we'll talk about is filters. In the filter aspect here, connections that are passed between Envoy transition between various filters representing different OSI layers. So you can have filters at the listener level, as mentioned, the network level. There's a few options up there, as well as more higher level filters like HTTP filters. So where does this apply in gaming? Well, this is where it comes to custom network filters. So this is kind of an area that might be an interesting use case for the kind of layer 3-4 transitions within your game engine. Not to say that, like I said, you'd want to go off and immediately try this out, but here are the options that we have. So we have read filters for parsing information about the event or the intention of a player, like my player is now dead, or here's the position of my player. Then you have the write aspect, where you can kind of assemble all of the information that you need before passing it on to the next host. Interesting things in here that I've thought about is there potentially a prioritization effort that you can make for that before sending them on? As we mentioned before, there's more important events than others. So being able to tell what's more important at this moment and then dropping that instead of sending everything would be an interesting use case as well. Then there's read-write for kind of doing all the above and assembling that together for an entire event cycle. Some features out of the box that would be interesting for someone working at the 3.4 level is the rate limiting feature. So we can imagine in this case, having a ton of players connect to one instance and then going over the limit that we have targeted that instance of the server at. And Envoy exposes some useful metrics. There's a small typo in there, but so after hitting a certain threshold, we want to start shedding traffic potentially off of a server that's particularly busy. And we can do this with either global rate limits. In the HTTP case, there's also more fine-grained with circuit breakers. And then we also have the ability to ignore them for possible events that we have that are just that important. The overload manager as well, I had kind of had a few instances where I thought it could be used for prioritizing packets. In general, this piece of Envoy is for noting things outside of Envoy's control under distress and reacting to them. So, for example, fixed heap size is one of the examples that are built into Envoy now. And this would be once it hits a certain threshold on the host, maybe there's too many processes taking up memory, and we're going to track that, note it, and maybe start shutting off features of things. So the use case that's brought up in Envoy at the moment is certain keep alive metrics. So maybe we don't want to keep alive, and we want to shut down that particular component's features. Some other additional built-in features for Envoy that might be attractive. There's the WebSocket support, gRPC. There are instances within game engines where you can simply just toss over gRPC calls. And Envoy has a very rich set of features for dealing with those as well as just generic service discovery. There's 5 instances here, ranging from just statically assigning these things to also the more interesting logical or strict DNS. In strict DNS case, you're going to be resolving these things every so often and updating your host dynamically based on what's returned from that. In the logical case, you're just getting the first one, and these are normally used for larger clusters that maybe are not changing in general, but don't want to have to take on the added perf hit of hitting or querying DNS every time and updating and adding things. Original destination is used quite a lot in the Istio case, where you're just grabbing whatever is redirected from IP tables and tossing it onto the end stream from there. And then there's the more dynamic approach called the Endpoint Discovery Service, as mentioned before. And this is just a basic example of some of the endpoints configuration. Another interesting aspect to kind of that would be interesting for someone that has persistent servers is Envoy's kind of management of itself. So in this instance, you can safely drain connections by a majority of methods. Some more simple ones, such as just posting to the admin health check API, as well as configuring health checks. Sorry for trying to take a picture. as well as having health checks. Currently, these are only mostly targeted at the HTTP example. However, we can think of extending these perhaps for a given use case at more of the layer 4 level. There's also outlier detections for making sure that these aren't a little too aggressive. So in the outlier detection mode, it's more of a passive model, whereby you're removing unhealthy hosts based on conditions that happen along the way. And this is important for Envoy's hot restart mechanism, whereby you can fully reload binaries or your Envoy binary without dropping connections easily. And this happens by utilizing Unix domain sockets and starting up the new process. New process fully initializes and then starts accepting some of the listen sockets from the old. So these were more of the targeted things if you wanted to put Envoy directly in the path. But I think there are also a couple of interesting use cases that could be made for just general game developers that don't want to modify their game engine code. So a lot of these come from kind of some of the more favorite things that I've heard from, like Matt Klein, mentioning how much he loves the statistics coming out of Envoy. And in this use case, I imagined using these statistics in a QA testing sort of mode. In this instance, you would have Envoy only running in your QA environments, and you can utilize the access logging to determine and check how you're determining players' position within the world, gathering metadata that you might find useful, like their connection rates, as well as just all of the general stats as mentioned before, connection speeds, player values from their previous connections so that you know how to intelligently matchmake them for the next game. The other example is kind of like I said before, the QA testing example. In this example, I can imagine using Envoy to simulate some of the poor connections that you might notice on particularly slow bandwidth speeds without actually physically traveling to that location. So you can use Envoy to inject in some sort of a fault or slow down the connection speed, note what it's like when players that have a particularly terrible connection are playing your game, and react to that. Some other future enhancements that are coming up in Envoy that I thought would be particularly interesting for the crowd would be UDP support, which has been is still in progress. There's been some enhancements recently to work towards the goal of like a UDP listener, as well as just general UDP proxying. I threw the issue up there, as well as Quick. And one issue sample that made me think that it was actually possible to use this within your game engine was a particular library from Valve that I found for the game networking sockets. This library borrows a lot of the some of the ideas from Quick in order to have message-oriented packets, so like you're familiar with UDP, with some of the properties that are more connection-like in TCP without kind of all of the overhead. So I linked the Valve library up there. This does not want to find my cursor. Okay. As well as performance is always being worked on with inside of Envoy to both lessen the amount of memory that Envoy is taking up with particularly large clusters, as well as just making sure that things are stored in a very performant way. WebAssembly support might be particularly interesting as well for people that are running across different platforms. Maybe they're using different languages. And Matt mentioned this on Monday, which I thought was very interesting, is some of the use case for mobile support. I don't have any more information about that, but I'm sure Matt will share it with us in the future. And some of the other last bits is just general platform support within inside of a game. Things like proxying voice, proxying messaging, as well as, like I said, tracking metrics for different events. So that is all I really have for today. I was going to demonstrate some examples, but based on feedback from almost every presenter I've talked to, the Wi-Fi has been very spotty. So I linked a few examples of use cases between bridging different platforms, like an on-premise one versus a cloud-based one. And I placed my contact information up there. That's basically all the slides I had now. So now we move to my favorite part, just generally gathering feedback from what game developers might like to see, and other just targeted questions. Any questions?
How far away do we really think UDP support is?
How far away? Well,
If
Is Matt in here? So the tentative goal was Q1 of next year. It's kind of lengthened out, partially due to my fault, partially just it being a complex thing in general. There's the stateful versus stateless UDP types as well that we want to make sure to handle. The big driver of it as well is quick, and I believe that at least some examples are supposed to be out within Q1 of next year for quick, and UDP is actively being worked on at the moment.
How do you control Envoy production?
Sure. So we can move on to this giant backup slides that I have here, where you can follow along for the XDS API. So this is the common one that a control plane like Istio would utilize for programming Envoy. It's very fine-grained at the level of the listener, the clusters, figuring out each individual endpoint. So you can use a lot of these sorts of APIs to program it, as well as maybe just dropping down to a more static configuration if necessary as well. Other questions?
So you use Istio?
Do I use Istio? Oh, I've worked on Istio, yes. I've started a transition to working a lot more with the Envoy community, but if you have targeted questions about Istio, we could talk afterwards as well. Other hands? Oh, go ahead.
Hey, a couple things. So you mentioned the Valve network socket thing, and that I know those guys address a couple things that I was hoping you could touch on how Envoy relates to them. One of them is, in UDP there becomes there's like a DDoS problem that the Valve network socket thing is kind of designed in part to address. But if you don't use Valve network sockets, you instead centralize. You have say a cluster with Envoy that has your extra game server. With UDP, is there a concern about getting DDoS, and is there some protection for that built in?
Yeah, so this kind of is related to some of those features that I mentioned towards the front about rate limiting as well as the overload manager. I myself have not started, because we need the UDP support there first, I haven't started to experiment with how that's going to work, but within the UDP proposals, these sorts of things have been brought up as far as how do we have like connection-esque like properties to be able to tell when something is stale versus when it'll be active and when we can remove it. I don't have the answers at the moment, but it is, like that given use case is something that's being discussed. Go ahead.
Have you done any performance testing to see how much extra latency is added by the hopping through Envoy versus the no-for?
That specific scenario I have not. So there's always going to be some amount of latency, of course, when you place something in front of the thing that you expected to tunnel right through. And the unfortunate thing about measuring this, and one of the reasons I think that Envoy doesn't post any official metrics is it's so context specific, both the amount of data being sent as well as the duration. In some of the large scale tests that we've done within Istio, we've noticed anywhere ranging from like 10 milliseconds to a bit more than that. And another great thing about Envoy is you can start to disable features that you're definitely not going to want. And some features add a little bit more latency just based on the amount of processing they need to do than others. Other questions? Go ahead.
What's the worst offender for adding latency?
The worst offender for adding latency? That's a good, I mean, the most obvious one to me is the mixer filter within inside of Istio. And essentially what this is doing is every so often it's bundling up and sending it over the wire, but it kind of introduces another component within the data plane every so often. Things like that where you're directing through Envoy as well as yet another thing are the big ones. Specific features within vanilla Envoy, I haven't done any measurements at the moment to know the biggest players. Other questions? All right. Well, I hope this was useful for everyone. I have a very limited set of business cards to give out if you really want, but please copy down my email here if you want to connect. And like I said, a lot of this was just a bunch of research that I've done and some simple cases that I thought where this could be useful, but I think there's a lot more that could come up with us just talking. Thanks a lot.